Hey guys, it's Miss Casey. I am filming a video going over a couple problems from the first assignment of your AP exam target practice. This is page 1. We're going to be going over Know Your Limits. If you have the electronic copy, the name of the file is just limits. Shout out to everyone who gave me requests for which problems to go over. In order to make the most of our time, I don't want to go over every problem, so this is a good sampling. Thank you everyone who sent them in. I encourage you for our next assignment to do the same thing so I can get a good idea of what we need help on. The first problem I'm going to go over is number 1. Now, I just want to remind you that when we're talking about limits, one of our best bets is to use substitution. So if I were to substitute 2 in here, I see right off the bat that to keep going, I'm going to end up with 0 at the bottom, which is a huge no-no in all math, including calculus. So that means I have to do something else. If I get 0 at the bottom, I need to do something else. I notice at the top is easily factorable using grouping. So that's where I'm going to start. I am going to factor the top of this polynomial using grouping. So if I have x cubed plus 3x squared minus 4x minus 12. I'm going to set some parentheses around my 2 sections. And I'm going to pull the greatest common factor out of each section. The greatest common factor of x cubed and 3x squared is x squared. That leaves me with x plus 3. Greatest common factor of negative 4x minus 12 would be negative 4. That would also leave me with x plus 3, and that's what I want. I want these 2 factors to be the same. So then I have x squared minus 4 times x plus 3 all over x minus 2. Now, I wasn't able to cancel anything out yet, so I'm going to keep factoring where I can. I see that this x squared minus 4, this is a difference of 2 squares, so I'm going to rewrite it as x plus 2 times x minus 2 times x plus 3 all over x minus 2. Now, this allows me to cancel out x minus 2, which is good because I don't want it on the bottom, and I'm left with x plus 2 times x plus 3. Now, if I were to direct substitute in 2 for this, so the limit as x approaches 2 of x plus 2 times x plus 3. Well, 2 plus 2 is 4. 2 plus 3 is 5. I can do the math. 5 times 4 is 20. So the limit for number 1 as x approaches 2 of that function would be 20. This is after I have factored and canceled. Correct way to write my answer would be the limit as x approaches 2 of x plus 2 times x plus 3 equals 20. Leave that up for just a sec before I move on to our next problem. All right, now what about if direct substitution isn't possible? So plugging in infinity, for example, like in number 7. This is not the type of problem where you're going to end up with just, you know, easy peasy lemon squeezy plugging in a number, see what you get. We have to do a little manipulation. Now, you might remember this trick from the very beginning of the year where I'm going to take each piece, I'm going to look at the numerator and denominator separately. I'm going to take each piece, I'm going to divide it by the highest degree variable. So the limit as x approaches infinity, I'm going to take cube root of x cubed minus 8 over 2x. So we have cube root x cubed minus all over 2x. Now on the top, I'm going to divide x cubed and 8 by x cubed. And on the bottom, I'm going to divide 2x by just x. Now, why in the world would I do that? Well, I know something divided by itself comes down to 1. And if I were to conceptualize thinking about plugging in infinity right here, if I take 8 and I keep dividing it by infinity, I'm going to get closer and closer to the number 0. So effectively, I can call that 0. Then here, I can think about 2x over x. I can think about the x's canceling out, and I'm left with just 2. Now, the cube root of 1 minus 0 is just 1. And then 2 is just 2. So my answer becomes 1/2. I just have to manipulate it a little bit by working with the numerator and denominator separately and dividing by the highest degree variable in the numerator or denominator. Notice on the bottom, I only divided by x. Whereas in the top, I divided by x cubed. So the limit as x approaches infinity of this would be 1/2. Questions so far? I'm just kidding. It's really hard to do these without having you guys to guide me with questions. I'm not going to lie. All right, number 11. The limit as x approaches 5 with that little superscript negative of x squared over x squared minus 25. Now, first of all, this is 5 approaching from the left. So I'm looking at less than 5. The other thing I'm thinking about is even if I factor this, even if I manipulate it, I still can never plug 5 into this. I will end up with 0 on the bottom, which means at 5, we have a vertical asymptote at x equals 5. Now, if you remember, that either means one of two things. My function is either going to be shooting up by 5 or shooting down at 5. So I really only have two choices of what my limit can be here. My limit can either be negative infinity or positive infinity, since that vertical asymptote occurs at x equals 5. Thinking about this, I then am going to take a number to the left of 5. So how about 4.9? And I'm going to conceptualize plugging it in. So 4.9 squared over 4.9 squared minus 25. 4.9 squared is going to give me, let me grab my calculator. .9 squared gives me 24.01. Subtract that 25 from that. So I would have 24.01, oops, divided by negative 0.99, and I get negative 24. Now I'm going to try it with 4.8. So 4.8 squared. Okay, 23.04 minus 25. So I have 23.04 divided by negative 1.96. Okay. While this is happening, my number, let me actually go the other way, 4.99. So we do 4.99 squared divided by that. my number gets lower. So I jumped from like negative 24.49. It's going to keep getting, the closer and closer I get to 5, it's going to get smaller and smaller and smaller, a higher negative number. So therefore, out of my two options, the limit is approaching negative infinity, not positive infinity, which was my only other choice because of that vertical asymptote. The other thing you could have done, of course, is graph it. If this was a calculator active question, though, it probably wouldn't be. I cheated by using my calculator. So sorry. Trying to keep this video under 20 minutes. So there you have it. Last one. Now, this one looks really weird, right? And in fact, I had to stare at it for quite some time because we have several things going on. We have a delta x approaching 0. We have a trigonometric function. And then we have that trigonometric function plus delta x minus sine, same trig function over delta x again. Now, this pattern, while kind of weird, you have seen it before. You have seen this version. Let me just cover that up. You've seen this version where we have f of x plus h minus f of x over h. So if I assign x to be pi over 3 and h to be delta x, what I end up with is this idea of a limit definition for the function sine of x so that's my function. And I want to know the derivative at pi over 3. That is what it's asking. This is a tricky way of rewriting the derivative. It is the limit definition of a derivative. It's just written really weird, where it's already been plugged in for you. It's taken the x plus h and replaced it with what they want x to be and what they want h to be. So instead of plugging 0 in anywhere, what I'm going to do is I'm going to derive sine of x, which is super simple. F prime of x is cosine x. Then I'm going to plug in pi over 3 because that's my actual x, not 0. 0 is h because we're working with a limit definition of a derivative. So I'm going to plug in pi over 3 for cosine x. So I have f prime of pi over 3 equals cosine of pi over 3. Cosine of pi over 3 is 1/2, and that is my answer for number 11. Again, I know that one's weird. They set up several other ones like that, including number 13, number 9, and that's it. I did look ahead at number 14. There is a list in our notes from Unit 1, which was back at like page 22. Might want to take a look at those notes to remember about these. There's these couple special trigonometric limits, and one of them appears in this, and it will be very helpful if you know it. That's all for today. Tomorrow, I want to film a video on the derivatives. This seems so derivative to me. There's 14 questions. I'd love to aim for 5 or 6 that I can go over. You can text me at area code 302-268-7421. You can email me, casey.versace@freearywilmington.org. You can comment on the Remind app or reply to me in the Remind app. To tell me which problems you want me to go over. I recommend you trying it yourself first or even previewing it before deciding on some problems. Again, this would be finding the derivative of each of these beautiful functions. Have a great rest of your day. I love all of you, and I'll talk to you soon.